Cool. So I wanted to give a brief update on the IPLD reflection stuff. And I know I've been calling it IPLD reflection, but the package is actually called bind node. So just to clarify, I left a link for the docs in master. That is in master and you can use it. It's not in the release yet, I think. No, it is in 0.10, but it's still, it can change. I don't expect it will, but it might. So there's essentially three top-level APIs. There's prototype. You give it a schema and or a Go type, and it gives you a prototype. You can decode things into build nodes. There's wrap, and the difference with wrap is that you already have a Go value, so you can wrap something that you build some other way and expose it as an IPLD node. And then there's unwrap, which does the opposite of wrap. It essentially gives you the underlying Go value, depending on what Go type you registered. And essentially, it supports inferring Go types from schemas. So if you give it only the schema, it will infer an anonymous Go type, doing roughly the right things. It will do things like use pointers for optionals and nullables, which is maybe sometimes a little bit extra. For example, if you have a map is already a pointer, so we will still use a pointer to a map, which is like a double pointer. So I might play with that later on, but for now, I'm just keeping it simple. And what I'm implementing now is inferring schemas from Go types. So it's the other way around. And that is a little bit trickier because schemas can do more things than basic Go types. Go types do have, for example, struct field tags, but schemas in IPLD can have map elements be optional. And you can't really do that with field tags. So I think my answer there is going to be, if you want that kind of custom schema, just declare the schema and use it. I don't think I'm going to make the schema inference smart enough to do that kind of fancy stuff. And then something that Hannah mentioned, because I asked her to review the API and she said, looks good. And she mentioned, think about CBORDgen, because pretty much everybody that's using something akin to IPLD in Filecoin, they're using CBORDgen. I assume they don't have an IPLD layer. They simply use CBORDgen to encode and decode Go types as CBOR, as DAC CBOR. So she mentioned, if you made this behave the same way as CBORDgen when it works directly with Go types and Go values, and then we hook that up with the DAC CBOR codec in IPLD prime, and if they're compatible, that would be a great story for this is how you can start using IPLD prime, because you just replace like 10 lines and supposedly it will just work. You don't have to do any code gen. You don't have to replace your types. You don't have to do anything else. And she mentioned two ways in which CBORDgen might be tricky. One of them is it ignores unexported fields. That's fine with me. I have to because it's reflection. And the other one is it uses pointers for optionals, which is what I'm doing anyway. So I think if I just chug along, it will be compatible and work, but I will be doing a bunch of tests, and I imagine some quirks are going to show up. And I'm going to stop here in case Eric has any thoughts. Because somebody told me that you have experience with CBORDgen, so, and it's not documented at all. So.
Something to look out for there if we're trying to make well-paved migration pathways for those folks is there's some type that's called cbg.deferred, and that may contain some amount of magic that I'm not super familiar with, so that might be fun. But I don't know how much, maybe that's not going to be a problem at all.
Thank you. I will look into that. And besides that, the only thing I've been looking at in terms of IPLD has been some UX improvements. So I talked about these last week. I implemented schema type prototype and basic node chooser, which are really simple, but they're kind of easy to do. I want to do node to basic Go value next. And I would still love to have common selectors in Go for like select all, that kind of thing. But I'm really not sure how to use the API for like the builder stuff. So if anybody has any pointers on that or can show me some examples on what these could look like, that would be helpful. But yeah, that's it.
Okay, before I forget on that last question, I propose that we should just write them as JSON strings in here doc format and parse them. Forget the builders.
Wait, so what do we expose in the API?
I mean, maybe we should also wrap that in like selectors parse JSON, but then just like the here doc and then set that to a constant.
Right, because I think the API should have a selector that people can just grab and use directly.
Yeah, and so then that should be either the selector or the node or both. And but writing that in a JSON here doc instead of the builders seems like it would also be kind of valuable as documentation, because that's something that somebody can then also like copy and paste and like run with it immediately, rather than trying to look at the builder code and be like, that relates to this JSON if I wanted to use it in an API.
Cool, sounds good.
Okay. I'll go next. So my list of things is just a lot of little tasks I've been hanging around, a lot of IPLD stuff with what I'm doing. Mainly, I've started off on this sort of IPFS collections journey, and did a lot of HAMP stuff. And so I was circling around schemas and HAMPs and stuff. So I've got a list of doc things I did. I've got, I promoted the carv1 spec in the new doc site because it was still in the legacy thing. So I promoted that into a structure that we came up with, and including a test fixture. I put a test fixture in there, and there's the test fixture file, and then there's a JSON descriptor of what's in it that tells you that you could run against that test fixture. So I even made a little utility in JavaScript that can generate those for carv1 and carv2 files, which is nice. So when I get the carv2 spec up, hopefully start the pull request today, I can do the same thing for that and just have this basic test fixture with the JSON file describing it, and then we can add more pretty easily after that. So that's a bit of fun. So that's a pull request on the new docs site. The HAMPed docs took Daniel's Filecoin update PR from the old spec site. I updated that for the current version of the Filecoin HAMPed, and then I transferred that pull request over to the new docs site. So that's up for, I think that's pretty close. It should be mergeable. I just wanted to optimize on that last schema. And then there was two schema fixes. One's a bug fix in the byte prefix union, and the other one is allowing inline bytes definitions in unions, because we're already using that, and it's kind of hard to do, to define links outside of unions like as an alias and then pull them in again. It's just really verbose if you have to do it that way. So a schema doesn't allow that. So this was a proposal to allow that for stuff that we're doing already. Those PRs are now against the new doc site. So if they go in there, then we need to start making these tombstones on the old site to point to the new. I did some car work. So the carv2 read support in JavaScript is sitting in a pull request. That works and it's fully tested and quite nice. Just need to confirm that that's the format of carv2, so that's the spec work is next. And I think there will be quibbles. There's some things in there that are, some choices that I think that there'll be quibbles about. Various people will show up and say that's weird. Maybe. HAMPed stuff. So I did a lot of work on the JavaScript algorithm base of the HAMPed. It was just a bit old, and it built up this craft through iterations of use, where we tried using it with a couple of different consumption patterns, and that meant that it built up a lot of craft in the way there's just too much code there to support these different usage modes. So I've just ripped out a whole lot of code and I've just cleaned it all up and did some TypeScript stuff in there. And that's mostly ready, but I think I might change that to deal with the new data model format, because the next PR is this other layer that I have that consumes it and makes it nicely IPLD. So there's a choice about where I put the data model mapping. But anyway, that's still a work in progress. Not a whole lot to do there. A couple of interesting things related. I was keen to get some IPLD schema work into the new collection stuff. And I really wanted to have some tools available in JavaScript. So I updated this library, JS IPLD schema validator that I have that will take a schema and give you a JavaScript validator object that a function that you can just apply to any JavaScript object and it'll validate it against the schema. I extended that so it'll make nice JavaScript modules, so you can sort of code gen these modules and then just load them and use them. And they've got TypeScript annotations. They lint nicely. It's actually kind of nice. And I experimented in a couple of places. One is now that the JS car pull request has one of these in it now to validate the header in both the V1 and V2 forms. Is that right? No, it validates the header. I'm just using this really simple schema just because I was keen to use that thing, and it works really nicely. And I also tried one against DAG PB, and that worked really nicely too. Validate DAG PB objects in and out. But the problem with that was that with DAG PB, I have these really verbose errors. Like if you give it an object that's the wrong shape at all, it'll tell you where the problem is. And I just don't have that level of detail with this validator. So I haven't actually committed that in there, but I tried it out and it was quite nice. So I'm looking forward to using that more. Keen to use it in collections because there's a bunch of places in collections where schemas come into play, and I also want to just bake it into the HAMT work as well. I just don't want to futz around with just objects that are the wrong type, and I want to make sure that in and out things are the right shape. So that's mainly what I'm keen for with that. And then lastly, to support that work, because I was using TypeScript partly to validate some of this stuff, I did a schema as TypeScript, which is in that pull request. I don't know, like it works really nicely for the schema validator, which touches all of the schema, but I don't know whether it's going to scale beyond that. I did try using it for something else on the weekend that I was fiddling with, and it sort of broke down for that use case. So it could be this kind of situation that we have with IPLD prime and Go IPLD schema, where these things are disconnected and there's a journey to connect them together. So I think I might merge that, just because it's a standalone thing. It doesn't really impact a whole lot, except if you explicitly pull it into some other project. So if it needs to be updated later, we can do that. But I'm pretty confident that it's workable as is now. But yeah. Anyway, I think that'll do me. So Eric.
Okay. So I get to finally say the new website, it shipped. It's on a public domain. The DNS is updated. Wow. IPLD.io. It's alive. This also included some really heroic work from Alizilla, who's not often on this call with us, but jumped in to help freshen up the sheer beautification of it. So we've got our super lovely splash pages back up at the root of the domain. Some really lovely animations and just good impressions. And then from there, you can follow the big nav links at the top to documentation, and that'll drop you into all of this lovely, rich new content we've got. There's still a large stylistic difference between the splash page and the rest of the content. Whatever. Beautification efforts will continue. But it's there. So now all of that rich content is available, and we can link to it using good old web URL things. In addition to CIDs, of course, because Fleek is kind of a cool web deployment technology. And so you can get all the snapshots of the website ever from like CID-based subdomains of their system too. It's cool. So I've talked enough about the website in the past though, so I won't talk anymore about that. It's just there. It's done. Yay. I tried to work a little bit on some of the subtler details of Go IPLD prime recently, and particularly around the concept of absent values and how they work. And this is kind of a painful topic. So zooming way back for just a brief moment, in IPLD schemas, we've got these concepts of, okay, when you're writing some structural definition, in the fields of a struct, you can say the field name and then the field type, and then you can add these annotations to it of optional and alternatively, or both, nullable. And so if something says nullable, it can contain null in addition to its other type information. And if it says optional, that entire field can be absent. And what exactly that means for the serialized form may vary, but for a struct that's encoded as a map, that means like that entire key name can be missing from the map, and then it will still match that data with that schema. And then the value that you get is absent instead of being null. And so you can have something that is also either null or absent. You can put optional nullable on the annotations, and those are two distinct things. So, but figuring out how to handle that then in your libraries wrangling that data is tricky, right? And anybody who has done any JavaScript can probably consider this similar to the way there's null versus undefined, and probably knows that in JavaScript that's also very tricky and full of odd little edge cases. I was hoping that we were going to be able to pull this off with fewer edge cases, but yeah, this is a naturally tricky thing. So a problem that we've uncovered right now is when you have the type level view of some information, you process this data with a schema. When you iterate over something, structs will act like maps, right? They'll give you a map iterator. And it will always iterate over all fields in the struct, including yielding you the key and the value pair with absent as the value. When you're working at the representation level of that same data, it just doesn't yield that key, which makes sense because that's what you would expect it to do if you're converting this into a serialized token stream, right? So at the time I initially drafted all of this stuff, that seemed to make sense, that you would want to always list all of the fields in your struct type. And then there's nothing else to do except have some unique value that says, hi, I'm the absent placeholder sentinel value. Now the bummer with this is we can also, because of some of our other goals around making type systems be just kind of a lens, the representation level implements the node interface in Golang, and the type level also implements the node interface in Golang. Sometimes that's kind of cool, but it means you can hand either one of those into functions like encode. And now the trouble appears because there's this little foot gun in there, where if you hand type level information to an encode function, the current implementation of those encode functions would silently coerce an absent into being serialized as a null. So we did all of this. Yeah.
So they weren't. The solution of that is to check for is absent at that level, or are you changing the iterator, or?
So that is something that we should actually debate. I'm not sure what the correct choice is here. So I've proposed a PR in the last couple of days where we do just in the codex check for absence and halt and report that as an error instead of trying to serialize something that's coerced. And that would fix the biggest foot gun, I think. Like, at least that means you're not going to get this silent coercion is bad, right? I can't believe I ever wrote something that did this. Like, obviously that was a mistake. Obviously. But there are some other debates to be had here. Like, yeah, should the iterator at type level actually yield that? Maybe that was a bad idea.
Is there any other way at type level to get information about what fields are expected? If the iterator just skipped over things that are absent, is there any way that, say you had a typed node and you didn't have the schema and you wanted to inspect that, and say you wanted to generate a schema from that, could you do that? Or could you look at all the fields and say, I need to fill in these 10 fields and they're all strings, I'm just going to put some random strings in there? is there any other way to figure out what's absent and needs filling?
Nope, not the way that we've currently implemented that interface.
So you need the iterator with the absent indicator.
Yeah, pretty much. We could also add the way that the Go is shaped. You could do an interface check to be like, is this a typed node instead of just a node interface? And then we have a method on those that does give you the schema information. I think there's some unimplemented things there, so that's a little bit of a trap right now too. But assuming that was all implemented, then you could go that road. So that does leave some options.
Off the top of your head, do you remember the other cases for exposing that on the iterator?
Daniel comments that the type info getting is implemented in bind node. So bind node is better than the code gen implementation that I worked on already. Good. Are there other uses for that? Honestly, I don't know. I think one of the things that I had in mind when I wrote this to yield absent was that it seemed sane at the time because it would result in structs when you ask them their length having a fixed answer, which just seemed right to me. But functionally, I can't say that this is saving me any time at this point. So I don't know. Maybe that's dumb reasoning. And I thought maybe it would help us write pretty printers more easily without having the pretty printer need to learn about the type system. But I also am now thinking that's a very weak argument.
Because if you want the type node to be just an abstraction over the node, then maybe trying to match the behavior closer is the right thing to do there. And if you want affordances to do fancy inspection or introspection, then build them elsewhere. But maybe this is one of those cases where it should just behave like a node.
Yeah, I'm thinking that's a distinctive possibility. Because some of the another alternative that's been proposed is some people would like to maybe have us update codecs so that they look at their argument, and if you do hand them a node and we do the interface check, is this a typed node? And if it is, then we should either halt and catch fire right there and say, no, you can't. Or take it an even further step and just silently call the dot representation function on it, which should give you the encoding representation. But personally, I think those are kind of wild. Like that closes an entire door to other features too, and I would feel very dubious about that.
So right now it's up to you to send it the representation, and the encoder doesn't do that.
And so that is also very arguably like a bad user experience, right? It requires the user to consistently remember to call that unboxing method. I don't know if unboxing is quite the word there, but like it requires you to make that transition.
That would seem to me to be a fundamental feature of this whole system, is that the encoder deals with representation only. That's what it's for. That's what the representation layer is for.
I think Eric's proposed change is better than what we have right now, because if we fall into that pitfall, having an obvious quick error is much easier to deal with than having data that will actually not decode later, which is what we had in Dealbot. A field was usually present, but one time it was absent and we encoded it. And then somebody tried to decode it, and then that blew up in their face like days later. And we didn't really know what happened. And it's sort of too late to fix the schema at that point because we've encoded weeks of data, with a non-representation. Having said that, I don't think it really fixes the gotcha because we didn't run into the gotcha for weeks. Because as I said, usually we didn't have absence. And running into the error later on would have still, caught us by surprise. It's something that you will run into depending on what your data is, not depending on what your type or schema is. So I think we should just have the codecs go to the representation by default. I don't see any reason why not, if I'm being honest. And if you want to avoid it, you can always hide the representation method in Go. You can wrap your node into another type that hides the representation method. And then the codec can't really, because if you grab So think about it this way. If you have a node that's typed, you can grab its representation, right? And its representation does not have a representation method because you can't go another level deeper. So you can sort of trick the codec into doing that, into thinking it's already got the representation by hiding the method.
Like handing it a proxy kind of object that will.
Yeah, it's essentially like an object that allows some methods to go through, but not others, like an allow list of methods. And then you block representation. You only allow like IPLD.node methods.
And you'd have to do that recursively. This is the other thing. To all child objects too.
I guess not, as long as the codec only does this check at the top level.
This is one of the things that kind of scares me about that whole group of solutions, though, is that it depends on where the codec function does it. And I'm scared that third-party codecs are going to choose to do stuff like this in different places, and it's going to be inconsistency there could result in like ecosystemic sanity damage. It'll result in people just scattering dot representation calls like everywhere in the name of safety, even if most of them are unnecessary, because you'll always be afraid you're interacting with some third-party codec that did it in a weird place or a different place or something.
I sort of disagree, because most people will be dealing with IPLD.node, not IPLD.typeNode.
I'm not sure that's a safe assumption though. As this thing matures, I would expect people to be using a lot of schema-based stuff.
Well, anyway, we've come up with some new ideas on this even as we're talking right now, so that's cool. I haven't been keeping notes fast enough. I think I'm gonna have to rewatch our video later here.
Yeah, but I should also clarify that what I mentioned about hiding one method is a hack, essentially. So I don't expect people would actually be doing that. It's just an example. So I don't think we should be, stuck on that, working or not working too much.
I mean, the whole question of ADLs as well on top of this is really interesting. So if you can pass an encoder a type node, can you also pass it an ADL node, whatever that's called?
And right now you similarly can. You could hand the view of a hamped node into the encode method, and it'll like just chug straight through it for however many gigabytes, petabytes, whatever. It's just gonna go. Okay. Amusingly, that'll work because it's all streaming.
Yeah, I guess it sounds like it's really a trade-off between the pluggability versus. Yeah, I mean, my inclination here is just to simply say, look, encoders are supposed to work at representation level, because that's literally what that's for. It's representation, and codecs are representing. So that's their job. So they should get down there as quickly as possible. And it shouldn't necessarily be up to the user to do that, but that's, maybe that's nice.
So the one thing that would make me way more receptive, to this is basically if I could figure out what our undo story is for that. Like if the user does want to try to use the type level thing and be running the type system lensing backwards like that. Because also to visualize why this would be cool, remember we initially drafted a bunch of docs around selectors to use the human readable names for the different clauses, because we thought that would, be human readable. It would be really cool to be able to use that. And right now, if you could plug in the node builders for the type level and say deserialize into this, you get that for free. We still have the weirdness. I think this is a very strong argument, by the way, for doing what you were saying earlier, Rod, and removing the absence special cases for the type level, because that makes this lensing just problematic. But up one in the train of thought tree.
One place where I can see this being useful is if you're using a codec for pretty printing or debugging. So if I wanted to use DAG JSON to show me what my object looks like now, and I don't want to do the representation level, I actually want to see it as a struct, with a map and not as some array with tiny little things.
Yep. So, and a big problem with this is we've got ourselves in kind of an awkward space in Golang where, like, I don't know, figuring out how to do the config objects is just weirdly troubling. This is something that would probably be laughably not a problem in JavaScript, but in Golang land, we have currently the function definition for encoder is something that takes an IPLD node and an io.writer and returns an error. That's it. Where's the config? I don't know. It's not there. And so this is like mostly a pretty good interface, and it's very, I think it's fairly like Gopher standard concept. But then usually the way you do the config for this is you've got some specific type, a struct somewhere that has the rest of your config fields in it. And then you're plucking the encode method off of that structure, and that's how you do the config. There's no interface here. So there's no standard way to expose an API that says, let's the user say, yes, please, I would like to use the type level view. I know what I'm doing. Please remove the safeties and let me do this. So if we had a standard way to say that in our Golang API, then that would be great. We don't right now.
Would that, I'm sorry, I don't quite grok what you're saying, but I think it's getting it. Something that we discussed last week about this map sorting in Cbor. If you had the ability to pass config options, is that something you could also do where, because the DAG Cbor not sorting thing, if you, like what we're seeing in the wild now is people are doing it themselves manually outside of IPLD Prime, like in that lib peer-to-peer example that came up last week. Is that something where IPLD Prime could maybe do DAG Cbor not sorted by default, but you could pass a config option that would say, I want you to sort my fields prior to encode. Is that something you could, that kind of thing could enable as well, where you're pushing config down into the encoder?
It would probably help. I think for the sorting thing, there's also other things that I wish that we had figured out a good way to do, like have nodes retain memory if they're already sorted so that it can memorize sanely and things like that. But like, yeah, it is probably accurate to say our lack of standardizable config options for some of this stuff is beginning to be a painful problem. I think we were going for a long time on the thought that, like, yeah, because we don't want to have config options even, because multi-codec indicators should literally say everything. And like, that seems to not be helping us design good libraries in retrospect.
Yeah, and like, if I want to, I still think I want to have the option to tell my DAG JSON encoder to pretty print.
Yep. Also really a great example.
That. Yeah.
Like multi-codec might be against that, but for good library design, yeah, I need that.
Yeah. Like I want to be able to abuse certain things of our perfect system to get, pragmatic outcomes. And DAG JSON is pretty print. Like I actually did in the the car test fixture. I used DAG JSON to generate the information about what's in there. So there's a text fixture binary file, and then there's a DAG JSON descriptor. But I didn't want to just dump raw DAG JSON because there's no spaces. And so I ran that back through a JSON encoder and decoder with pretty print. I just want to be able to do that with DAG JSON. So I want to have some way to force that down into that encode decision. And right now, even in JavaScript, I don't really have that. But because these things are not as like layered as IPLD Prime, I could do that fairly straightforwardly. But I can see with IPLD Prime, the problem of having these sort of encoders plugged in the back end, and then you're dealing with it from this front end. You sort of, it gets a bit.
Yeah, and it gets, so if we're doing config stuff like, okay, the white spacing, that could arguably be, that is legitimately like a DAG JSON specific thing. Like that config option is not going to be totally normalized across every other codec ever. This thing with, should we automatically coerce type nodes to their representation view? That would actually be an option that we would want to be consistent across every codec ever, right? And I think this is the first example of something like that we would actually want to be consistent across every codec ever. I don't think we've ever hit one of these before in our history here. So that's fun.
We should probably move on, shouldn't we?
Yep. Good thinking, though. Good notes. That was all I had for my segment. I don't know if that leaves us with any more or what.
I want to talk about selectors if you have the brain power still.
Oh no. Okay.
So back to the GitHub issue, where there was a very good discussion of how what I'm doing is not great and how we should do something different, except I never got what the difference should be. So I put the actual signature in the HackMD at the top. I understand exactly why you dislike this. What I'm confused about, what should I replace this with? Like, this never was voiced.
Okay, first of all, technical note. Please press F5
Yes.
somewhere. I don't see the snippet.
It's right in this meeting.
It's
Agenda general this meeting and
in the agenda at the top there.
yeah.
Okay. Let's make that copy down the bottom.
Sorry. So I understand why you don't want to use in and out builder selector spec, but what I didn't get is what can I actually replace this with today or tomorrow or in a week?
I would have it take and return IPLD nodes, which is weird only because it doesn't say what it means very well. But
is there like an actual cast I can do after that or something, or like how do I?
Nope. So I think the ideal thing that we would do here is revisit the selector implementation and make sure it has actual nice types. History note, how we got here. We wrote the selectors before we had any of the code gen, way before we had the bind node implementation that Daniel's now got. And so we used the basic general purpose node, the anything grab bag node type in order to do all of the selector stuff. And so we don't have a concrete type that contains that data model tree and means that it has been validated. If we wrote this again today, we would have that. And it would make this API make immediately much more sense. But if you're asking what you can do today before we dive into that rabbit hole, I would say, yeah, then that means you should use the type is not very descriptive IPLD.node, because that's the most logically correct thing, even if it's not very type system descriptive.
Just so I'm on the same page, this API would be used directly by developers, right? So it seems to me like what he's proposing here is easier to use. That's something that takes and returns high-level abstract IPLD node types. So I think that's what he's trying to say.
He being Eric or me?
Being Peter, sorry.
Okay.
Because this returns, so if I'm looking at the API, this takes an expression and gives me a selector spec. That's much easier to understand. That's something taking a node and giving me a node. Like I really wouldn't know how to use that.
And my question is even on the other side, like, okay, I can kind of see from an existing selector how to make a node, feed it in, and then pull a selector out. That's fine. But on the inside of this function, which I have full control over, I wrote its insides. I don't know how to let me get to the function. Hold on. Function is so I need to do stuff like this, for example. I'm going to put it in the HackMD on the bottom. Stuff like this. Like, how would I actually do this with an IPLD node? where I effectively SS is my selector spec, which I keep like decorating more and more and more. And then I return the final decorated thing.
So that, I'm going to re-describe that line briefly for whoever's looking at the video and doesn't have the text file in front of them.
Yeah.
It's basically just a line of a function call that has a selector builder, and it says explore index, and then the parameters are the index and then the rest of the selector spec that's already been built above, and it returns the selector spec again and then rolls forward. All of that function is doing, if you jump inside of it, that explore index on the builder, is it's literally making a map with the key index in it and then putting the index value in it. That's your argument there. And then it's making another map key that's like the pointy character, which semantically means the next field in selectors. And then it's putting the rest of that in there. Like that's all that function is doing. It's a thin wraparound making a map. So I think the amount of magic that you think is going on there, like there's not much going on there. And so I don't know if you saw one of the alternative builder PRs that Hannah made recently, but that also provided like, this alternative way that's a little more, that has fewer steps of indirection. I kind of liked it. I don't know if we're gonna run with that or what, but
it was horrifying, like from my perspective.
Okay, so over both or what?
Yeah, it was like it looked like a bare abstract syntax tree, effectively,
right,
written by hand. Okay, here's my actionable, because like this is something that I can still modify for now, but when it ships, when it actually merges into Lotus, like it's baked, it's kind of set in stone. So if you're saying like this particular function should take an IPLD node and that non-IPLD node, I guess I will just figure out how to do that. And based on what you're saying, it shouldn't be that hard, or it's actually not that hard from your perspective, and I just have to copy this thing that that I put together, which, I mean, it's internal, so it doesn't really matter, but it's effectively maintainable from my perspective. But yeah.
Yeah, let's try it and see how bad it is, and then see if we can make it less bad. And if it's really, really bad still, we can go back to this. But I think for things that we want to continue to see and experience in APIs for a long time to come, I think the bare nodes would be more correct. The thing about having the bare nodes in this kind of function signature is that it definitely sucks in the sense of it says less, like it gives us fewer hints. The type system is not documenting as well the linkages here, and the compiler is checking fewer things. But I'm afraid that if we put some of these other types in here, it makes something load bearing that is not like actually essential to the work, and it's going to make things much scarier to refactor in the entirety of the future. So
that's fair. So right now, this function that we're talking about is called selector spec from path. Obviously, what I'm going to be getting back is not a selector spec anymore. What is it? Like, what is the name of this subtype of IPLD node that I'm actually getting out?
So this is the stuff I started calling DMT. It's the data model tree specifying a selector. Data model tree, as opposed to AST.
Can I call it selector node or something?
Sure.
Because it needs to make sense to people not named Eric and not living in Oslo. So, you know.
And then when people in Silicon Valley see DMT, they think of other things.
No idea what you're talking about.
Okay,
it's just a very convenient acronym.
Yeah. Okay, selector node. I can work with that selector node, and it takes and returns an IPLD node, which implies that, yeah, what this node is. Okay. And how to make this work inside, we'll figure this out. Yeah, okay, this unblocks me. This gives me a way forward. Cool.
Good.
So, are we done with that one? Is there anything more to discuss there?
Just one quick...
Then, yeah, go ahead.
Oh, go ahead.
I was actually going to ask you if you have any remarks, because you are the API person.
I was going to ask Eric, like the reason we want QP in general for IPLD prime is because it works with any prototype, it's generic, right? But HANA has QP that only works for selectors. That's like specifically for selectors, selector nodes, sorry. Supposedly we could make those selector nodes like non-code generated and easier to construct with Go expressions and then use something like bind node on top of them. Is that something that would make it easier than, say, HANA's QP or something else?
For me and for others listening, what is QP?
So QP is, you saw HANA's PR?
Yeah, but what does it stand for?
Oh, my QP is a copy of Eric's QUIP, which I think was like quick prototype or something like that.
Stands for nothing.
So it's IPLD prime specific. It's not. I was thinking, oh, this is
it's
some
a truncation
weird
of an acronym of a joke. It's a stands for nothing.
Thing. Okay.
And I chose QP because I'm very lazy and I didn't want to type more than 2 characters every time I have to use it.
Oh my God, Go programmers. Okay, moving on.
Yeah. Side note, I really wish Go had a syntax for it. I'm going to import this package in this lexical block and like have short things. Guys, some days I wish that I wrote Ruby.
How do I mute somebody? Sorry, Peter, go ahead.
No, I have nothing.
Oh, I thought you were going to say something, sorry.
Nope.
So, acronyms aside, I think we're kind of like coming up around some interesting ideas for how to deal with some of this stuff in Golang. Golang is not a good language for doing DSLs in, as far as I can tell. It is just like syntactically, there's not a lot that you can
unless you just
run with.
Code gen everything.
I mean, some parts of me really like this too, right? It means nobody's going to get too fancy on you and do scary things. Oh, yeah, generics are coming. I still don't know what that's going to imply for some of this stuff. But this idea that we've kind of started orbiting here with some of this QP stuff is we can have a bunch of functions that are kind of gathering up all of the construction operations we're going to do for this data. And then you can keep gathering those functions into larger and larger trees of functions. This is beautiful Lispy wonderland.
I was going to say, Lisp macro land.
Yeah, and then at the end you like just plonk that whole tree of functions on top of either a prototype or a builder, depending on how hard you want to control your allocation strategy, and then it goes. And this is just really, really elegant because when we look at how that turns out, we can make these function trees that bind up all of the logic that's relevant to a domain. So you can make some functions which know what the structure of selectors is supposed to be, and thus gives you a bunch of compile time checks and a bunch of like nice authoring tools related to that. And you can still apply them on any kind of node implementation you like. That's just like been separated. This seems to be a really cool pattern. I think it's still like not super obvious how you write new code that does this. We haven't turned this into like a playbook yet, but I think it's kind of cool. And also it's surprisingly efficient. Like I thought that this kind of tree of functions thing would just like be horribly unperformant and create like garbage all over the place. And somehow it doesn't. I don't actually understand how the compiler is being so cool about this, but like the benchmarks are good. So yeah.
But interesting, while we're describing this, I'm actually thinking back to the practical matter of what this function actually does. It takes an opaque selector and prepends a path to it. So effectively, it starts from the back of this pass and exactly like wraps a selector against the existing selector, then wraps another one for the next segment, and it gives you the entire thing back. It's literally the point of this entire thing.
Yeah, so I guess a thing that's a bit weird about this QP style interaction is now there's like two different ways you can compose, and one of them is to keep stitching together those function trees that are all going to apply themselves later, and one is to have a dang value and like plug it into other values, and those don't quite touch.
Right.
I don't know. I think we've got interesting API research to go there. Like it feels like we're getting really close to a repeatable pattern for ways to do cool, useful Golang DSLs for this stuff. But I don't think we've 100% nailed it yet. There's still research to do.
But research aside, what's our conclusion for Peter for like next week?
I would still do node values. That's the least likely to make us sad.
Yeah, node values, I will rename the function to selector node from path or whatever the name was right now. Basically, I'll have selector node in the name, which basically tells you what this IPLD node actually is. And I will be bugging you throughout the week of how to actually make this work. I have tests and everything for it, so I will know when it works. So
good.
Yeah.
One last quick idea is we could use Golang alias for this too, just to like give us a type name to attach for documentation purposes. And it would just be an alias of IPLD node right now, but we could like write a short paragraph describing all the stuff we just said and why this placeholder for docs exists. Might help.
I actually have no idea how this works, but I'm making a mental note to, like, when it is written, to ask you again, like, okay, so this alias thing goes where?
Perfect. Okay. Hey, we used the whole dang hour. Wow.
There was a whole line of other topics that we last week in a meeting, we were like, we should definitely talk about this in the IPLD sync. This is really good stuff and we need Eric's input. And it's just completely been forgotten. We have no idea what we were talking about. So, which is really annoying. But it could be related to something that has come up in the context of collections. I don't want to extend this meeting, so I just want to seed this. The thing about collections is that collections will end up essentially being this totally schemaed thing with an ADL in the middle of it, but at the edges of it, you're gonna want to attach things that have their own schema. So it's a system. It'll be a system that has these hard constraints in the middle of it, but we want users to be able to take this system and then use it with their own schemas on the edges. So it's a collection of things that I schema. So we have this double schema layer thing, and early on, Will did make the point where he was like, "Well, yeah, with collections, I want to be able to have the nice type nodes all the way out into my particular collection. So the collection itself takes care of all the, building the data on the inside. But then when I'm interacting with the data through the collections interface, whatever it looks like in Go, I want those edges to be also typed for my particular schema that I'm collecting. And so I have no idea how that's going to work in Go with IPLD Prime, but that's just something to seed for future thinking, where we want to schema on top of schema with an ADL in the middle. And yeah, seems messy to me.
Yeah, I would start with using ampersand any.
And that's
you're jumping
that's exactly what it'll be. But then you hand it off to the user, and here's your IPLD node. Go. Like, that just doesn't seem very friendly as a complete system. So they're having to essentially cast or whatever that operation is.
I think that we could also think about introducing macros to the schema system at some point. There have been some times where I've been starting to think that might be useful, but I don't know if that would be the appropriate solution to this either, because if you did that, then what you would end up is a whole family of types that's like all of the collections high-level preamble stuff, and then like somewhere deep down here, instead of ampersand any, you've got a specific thing. And now, well, all these types ended up weirdly specialized, didn't they?
And then the user experience is, if I want to use collections, I have to take the full collection schema, including the ADL garbage in the middle, and then I have to paste that, and then I have to put my stuff at the end of it. It just doesn't seem like a nice solution.
Yeah, it sounds like generics in other programming languages, but I don't know if I want to assume that generics exist in all of our target languages, so that it's a whole ball of wax.
In terms of Go, this might be a bad idea, but you can have schema types. You can hold them as Go values, and you can, they're pointers and they have fields to other pointers and stuff. You could have the collections schema type and then have something that's an any, and then replace that with something else that's specific to how you're using collections. So it would be like injecting, you have like the schema for collections, your schema that you're actually holding for your application, and then you join them at runtime.
So at runtime, the collections would be exporting you that schema and saying, or exporting your method to say, insert your own thing here.
Right, and that would not work for CodeGen, I imagine, for example, because you're doing it at runtime. But if you're doing things at runtime, then it might just work. And wink, wink, that's where bind node could work. But I'm just guessing it would work.
I think whatever the solution is to this, it should be taken slowly, because it sounds a lot like generics to me, and that's...
It definitely is, yeah. It's a collection of type T.
Yep.
The other thing that will be interesting here is that I want the schema of the edges to be actually embedded in the collection, like near the root somewhere. So the collections API should already have the schema of that it's looking at the edge. So if there's some way to use that information at sort of runtime or load time to say, when I get down there, I know what should be down there. It may not give me CodeGen, but the user, like, that should just emerge out of the data itself in read cases anyway. Anyway, I don't want to take that time. We're past the hour now and it's late for Europe. So it's just seeding thoughts to come up later with.
All right. That was an exciting meeting. See you all in whenever the next one is. A couple weeks.
Couple weeks.
Yep. Thanks for anyone who